All right, starting with rotation and revolution. What does rotation mean? What's rotation, Colton?
The rotation is like the Earth spinning on its axis.
Right, so it's this movement, right? The real Earth doesn't squeak, but it's this movement. So that causes what? Rotation causes what, Elena? Night and day, and one rotation takes how long, Kara? One rotation.
A day.
A day, which is also 24 hours. What is revolution? Sarah? Good, so that's this motion, right? Revolution around the sun. How long does one revolution take, Sutton?
365.25 days.
Good, just over 365 days. And what else did it say? Why do we experience seasons? What's the reason we have seasons, Noah?
I have a question.
Oh, sure.
If you were to ask, like, how long does a revolution take, would you accept just 365 days instead?
Well, remember, it's a multiple choice. So if the answer 365.25 is given, that's the correct one. Okay? Ellie?
During orbit, Earth tilts on its axis, causing the two hemispheres to be different distances from the sun and causing seasons.
Okay, remember, it is the tilt of Earth's axis that's responsible for the seasons. Yes, it has to do with the revolution as well, but it's whether, if we're tilted, if the northern hemisphere is tilted toward the sun, what season is it? Summer. If it's tilted away from the sun, what season is it?
Winter.
Winter, and if it's somewhere in between,
Summer.
it's either spring
fall.
or fall. Good. That got moved. Rehan, can you tilt it back straight? Thanks. Okay. Why is it warmer at the equator than at the poles? Why is it warmer here? Luke?
There's more direct sunlight at the equator.
More direct sunlight. Remember, it's like me holding a flashlight out here. That flashlight's gonna be more concentrated at the equator, and it's gonna be more spread out as it reaches the poles. Awesome. All right, let's move on to equinox and solstice. I'm on freeze, that's why. Great. What are the dates of the two equinoxes? Approximately, there can be a range, right, depending, Lucia?
March 21st and September 21st.
Yeah, approximately it's, let me see if I can write on here. March 21st, whoo, that just moved something, and September 21st are the two equinoxes. What about the two solstices? When do those happen? Isak?
June 21st and December 21st.
And again, remember those dates can slightly vary because of that extra 6 hours that it takes per year. Sometimes it gets bumped to the next day, the 22nd or the 21st, but those are all approximate. Which of these has the shortest amount of daylight? Which of those 4 days? Shortest daylight, Rehan?
December 21st.
Right, so the winter solstice, so what you'll notice is we're approaching, so it's December 8th. As we approach December 21st, the daylight gets slightly shorter and shorter and shorter, but then after the 21st, it actually gets slightly longer and longer and longer. And the longest daylight then would happen when? Kara?
In June.
In June, yeah, the summer solstice. Great. Gravity and inertia. What's the definition for gravity? Jaren?
A force that attracts all objects toward each other.
Good. Force that attracts all objects toward each other. Remember, it doesn't work in one direction, it actually works in 2 directions. What's inertia? Colton? No, that sounds like gravity.
Oh.
And remember, gravity is a force that attracts all objects toward each other, not just toward the earth. Do you need a help? Help a little bit? Okay. Noah, what's inertia?
It's like the resistance of something coming towards.
Okay, we have a better definition than that, I think. Sarah?
The tendency of an object to resist a change in motion.
Okay. The tendency of an object to resist a change in motion. What that means is an object will keep doing what it was doing, unless, of course, a force stops it. So in space, remember, there's microgravity, right? There's very little gravity, and there's no air. There's no air resistance, there's no friction, there's none of that. So the reason that the planets stay in orbit around the sun and the moon stays in orbit around the earth is because both gravity and inertia work together. If gravity was acting alone, if it was just gravity, what would happen to the moon? Kara?
It would attach to us.
It would be pulled right into the earth, right? That doesn't happen because of inertia. The moon has always been moving, and technically it wants to keep moving in a straight path, okay? But it can't do that because of Earth's gravity. So the reason it stays in orbit is it was moving because of inertia, it'll continue moving because of inertia, and it stays in orbit because of Earth's gravity. All right, moon phases. Draw and label the moon phases in order, starting with the new moon. So let's do this.
I did off the back of my paper.
That's perfectly fine. I hope that when you drew these, you shaded the new moon in completely. Because darkness, okay, is represented by that shading. So the new moon. And then, remember, everything happens from our perspective on Earth, from the right. It begins to get light on the right. So what is the next phase called? This is gonna take forever, but you get the idea. What, that's a crescent shape, right? What would that be called, Rihan?
Called the waxing crescent.
Good. Waxing, remember, is gaining light. Did I spell crescent correctly?
Yes.
Okay, good. All right, and then it gets half lit on the right, and we call that what, Luke?
First quarter.
First
What if
quarter.
I did it on the opposite side? What if I colored it the opposite side?
Then it's the opposite, moon. If you colored it over here, Ellie, it's a third quarter. All right, and then it gets almost completely lit on the right, which is a waxing what, everybody? Gibbous. Gibbous is almost all lit, but not yet full. And of course, the next one is full moon. And then it starts to get dark on the right. So that little bit of darkness on the right still leaves most of it lit. This is a waning what? Waning gibbous. And then third quarter. And then waning crescent,
And then,
and then it goes back to the new moon. You need a tissue, you can, they're over there, you can hop up and grab one. All right. Why do we see different phases of the moon from Earth? Elena?
Depending on how much of the left side of the moon is
So, right, from our perspective on Earth, We know that the moon is always half lit, right, no matter where it is in space. But we only see certain portions of that lit side as it revolves around us. All right. What is responsible for the light we see on the moon, Jaren?
The sun's rays.
The sun, right? The sun's light is reflected off the moon. How many days are there in a lunar month? In other words, from new moon to new moon, how many days is that? Sanjay?
29.5.
Okay, 29.5. But let me just explain. That's not the amount of time it takes the moon to make one complete orbit. Okay? The amount of time it takes the moon to make one complete orbit is how many days, Rihan?
27 days.
Say that again?
27.
About 27 days for the moon to orbit. The reason that there's an extra 2.5 days added on to the lunar month is because the Earth, remember, doesn't stand still throughout this 27 days. It has moved ahead in its own orbit a little bit, so it takes about 2.5 days for the moon to get caught back up. Does that make sense? Okay. All right, moon features. What do Maria look like from Earth? What are those, Colton?
Like dark spots on the moon.
Yes, those are those big dark splotches that you see. And what are they? What are they really made of? Luke?
They're like, when a crater hits, when a crater's formed, lava seeps in sometimes.
Yeah, so they're ancient lava flows is really what we call them. But you're right, there were craters at one time that got filled in with lava. And that lava turned into what kind of rock? Who remembers? You remember the name of the rock? No?
Moon rock.
Not moon rock. Sarah? Basalt. Yeah, we're gonna learn a lot more about basalt after the first of the year. Good. How does the moon's lack of atmosphere affect it? It doesn't have an atmosphere, so how does that affect it? Kira?
Like it has more meteors hit it, and it's just a lot more dangerous than Earth because it gets hit with meteors and
I want you to think about one more thing. You're right about the craters. It has no protection from anything heading toward it, so it has a lot of impact craters. Tell me though about the temperature also. Elena?
Since it has no atmosphere and the atmosphere acts like a blanket, it either gets extremely cold when part of it's not facing the sun, or extremely hot when it's facing the sun.
Good. So remember the temperature extremes. There's no regulation. As you said, the atmosphere helps regulate the temperature. Without it, it gets really, really hot in the sunlight and really, really cold in the darkness. The moon's orbital plane. Remember, the orbital plane is how, whether it orbits on a flat plane along with the Earth, or if it's tilted somewhat. So the moon's orbital plane is tilted about what? Sanjay? 5 degrees. And remember, if it wasn't tilted, what would we see a lot more often? Luke? Eclipses, yeah, and we're not lined up that often. The moon's pull of gravity compared to Earth is about how much? Sutton?
1/6.
1/6. So a 100-pound person would weigh approximately what on the moon? Noah?
16 pounds.
You said 16?
Yeah.
How did you figure that out?
100 divided by 6.
100 divided by 6. Awesome.
More 7.
Is that what it is when you round it? Is it closer to 17? We should,
It's 16 and 2/3.
then it would be about 17. Okay,
I just rounded it to 17.
let me erase some of this. All right, let's move on to eclipses. What is an eclipse? Kara?
Well, there's two types. There's the lunar and solar.
Okay.
It is the moon, sun. I don't really know how to.
Well, it's something's shadow
It's something shadow, but
falling on
falling on Earth.
something else. And it's not always Earth's shadow or moon's shadow, but let's sketch them. Okay, so an eclipse is, again, any planetary body, any moon or any planet that can cast a shadow onto something else. So let's sketch what lunar looks like. Now it depends, of course, on which side you put the sun, right? But a lunar eclipse, remember, is when the Earth's shadow falls on the moon. So it should go sun, Earth, moon. Obviously, if you drew that the opposite way, it would go sun, Earth, moon. Solar eclipse is the exact opposite. It's when the moon's shadow falls on Earth. So in the solar eclipse, you would have sun, moon, Earth. Questions about that? Okay. Umbra and penumbra has to do with the shadows. So what's the difference? Stella, what's the difference?
The umbra is the lighter part of the shadow and the penumbra is the smaller part, or is it the opposite?
Use the words lighter and darker part.
The umbra is the lighter part.
Nope, guess again.
It's the darker part.
Darker
And the penumbra is the lighter part.
is the lighter part. Good. So I don't know if you've ever noticed that with your own shadow, if it's cast on a really bright sunny day, there's always a darker portion of your shadow, and then just outside of it is kind of a lighter portion. You can think of it like that. The umbra is that dark portion. And of course, remember, if you're inside the umbra, are you gonna see a total eclipse or a partial eclipse? If you're in the umbra, you would see a total eclipse. If you're in the penumbra, you'd see a partial. Okay. During what phase of the moon does a solar eclipse happen? In other words, when these three are aligned like this, what phase of the moon would that have to be, Lucia? The new moon. And of course, during which phase of the moon do lunar eclipses happen? Obviously, it would have to be what, Ellie? Full moon. And which type of eclipse, meaning lunar or solar, are you more likely to see, and why? Isak?
The lunar eclipse you see more because the umbra is larger.
Yes, so to maybe expand a little bit more on that, you're right when you said lunar eclipse. Because Earth's shadow falling on the moon is much larger than the moon's shadow falling on Earth. Okay, good, so far so good. Let's go on to tides. Do you guys feel like you've learned a lot? I hope so. This is a lot of information. All right. What do high and low tide look like at a coastal beach? If you were describing it to somebody that's not seen it, Noah, what would you say?
Like, the water can either be really high on the beach.
Yeah.
Or it could be low on the beach.
Great. So the water slowly moves up the beach during the day and then will go back down toward the ocean. How many low and high tides does each coast experience per day? Sarah? 2 high tides and 2 low tides every day. What causes the tides? Kara?
The moon and the sun's gravity.
Great, I'm glad you said moon and sun, because we can't forget the sun is involved, but which one has more of an effect on our tides? Everybody? The moon, definitely. And we just answered that entire question. And of course, the moon has more of an effect because it's closer. It's closer. All right, what is a spring tide Rihan?
The greatest difference between high and low tide.
Good, that's the greatest difference between high and low tide. During which moon phase does it occur? Remember, this is when Earth, Moon, and Sun are in alignment. Actually, it can happen during which two moon phases? Sanjay?
Moon phase or the full moon phase?
New and fall. Good. And sketch the location of the Earth, Sun, and Moon during a spring tide. Well, it could be one of two pictures. You could either have that drawn or that drawn. Spring tide. Okay? Neap tide, what's that? Colton.
The least difference in tides.
Good. And which two moon phases does that occur during? Luke?
First and third quarter.
Okay. First and third quarter. And the location of the Earth, Moon, and Sun. You could have either had the moon in that location or in this location. Again, because they're pulling, their gravitational pull is acting in opposite directions. That's why neap tides happen. All right, let's move on to the sun. So you have the Sun Web Quest. Remember, we don't have notes in our notebook, but you should have that Sun Web Quest in your folder that you would have used to cover this portion. So when I say element, I'm talking about elements on the periodic table. So which two elements make up our sun, Isak?
Hydrogen and helium.
Hydrogen and helium. Where in the sun does nuclear fusion take place? Sanjay?
In the sun's core.
In the core. What is nuclear fusion? What does that mean, Elena?
Nuclear fusion is when atoms fuse together to form new elements.
Did you say atoms fuse? Okay. Fuse together to make a new element. And in this case, it's two hydrogen atoms that are combining with enough force to form a helium atom. Why? Because the sun's gravitational pull is so immense, that core or that center is squeezed so much that nuclear fusion happens on its own. And a lot of energy is given off because of that. So therefore, the hottest part of the sun also happens to be the core. Yeah. Any questions about that? Did you have a question, Kara?
Yeah. How come do hydrogen atoms combine to make a helium?
So, okay, so you haven't probably studied much of the periodic table, which you will in 8th grade science, but I can tell you that hydrogen is element number 1. And what that means is it has one proton in its nucleus and one electron outside of it. So what helium happens to be element number 2. So what that means is when you combine two hydrogen atoms, now they'll have 2 protons and 2 electrons, and that happens to be an atom of helium. Does that make sense? So the opposite can happen too. And I don't want to get more into this, but if you've ever heard of splitting atoms, taking an atom and splitting it, that's called nuclear fission with an I. So fusion is bringing them together, fission is splitting apart. Noah?
Was it basically saying 1 plus 1 equals 2?
Exactly. That's in very simple terms, that's what it's saying. Yep. Luke?
Do trees do like a sort of form of fission?
Say that again?
Do trees do a sort of form of fission?
No. Fission, again, would happen in a nuclear reactor power plant because it's incredibly dangerous and it gives off immense amounts of energy and radiation. Okay. Stars. How is the temperature of a star determined? By its what?
Color.
By its color. Let's review. What is the hottest color star? Everybody?
Red.
Blue. And then white. Blue, white. Think about a flame. Think about the hottest parts of a flame. Blue, white, and then you've got yellow, orange. Red is the coolest. Not cool, you know what I mean. Cooler temperature star.
Yes, right.
How many constellations are there? Are celestial spheres divided into how many, Sanjay? 88. Which star points true north in the northern hemisphere and has been used forever and ever and ever? Elena? Polaris, also known as the North Star. If you've ever noticed the snowmobile company, Polaris, did you ever notice their logo?
No.
It's a star. Anyways.
Okay.
Okay, why do the stars appear to, they don't move, right? But why do they appear to move location throughout the night? Rihan?
We don't stay in one place, we keep them revolving around the sun.
Well, right, because we're, what is that called when we're spinning on our axis?
Rotation.
We're rotating. To us, it appears that they're moving when really it's Earth that's rotating. What happens to the position of stars throughout the year in the night sky? Colton?
They like shift. From
They- What do you mean by
Looks like-
shift though?
like it looks like they shifted.
Yeah, I mean, sometimes the Big Dipper, we looked at the Big Dipper, which remember is an asterism, it's not a constellation. But sometimes it's upside down, sometimes it's on its side, sometimes it's right side up. And why is that? Elena, why does it change?
Because the Earth revolves on Saturn and then which point the Earth is in its orbit or
Right, good. All right. Let's move on to meteor, meteoroid, meteorite. What's the difference between those three? Really, they're all the same, right? Noah?
A meteor is the shooting star.
Okay.
A meteoroid is when is the meteor entering our atmosphere, and a meteorite is when the meteoroid makes it through the atmosphere and touches Earth.
Awesome. So when it's outside of our atmosphere, we call it meteoroid. When it's in the atmosphere, it's a meteor. When it's hit the ground, it's meteorite. Shooting stars are simply meteors being burned up. Who remembers what layer does that? What layer of the atmosphere? Everybody say what? The mesosphere. The mesosphere burns meteors. Okay. Earth, solar system, Milky Way, galaxy, universe. If I had you order those from largest to smallest, how would they go? Sutton?
Wait, smallest to largest, or
Largest to smallest.
universe, galaxy, or Milky Way galaxy, solar system, and Earth.
Okay. And remember, it's kind of like nesting dolls, right? They're all a part of one another. The Earth is part of the solar system, which is part of our galaxy, which is part of the universe. Did you have a question, Elena? Okay.
So for like stars, like sun, stars that are like the sun, aren't white dwarfs? So if the second hottest kind of star is white, and white dwarfs are old stars, does it just mean that white dwarfs are bright?
Yes. They're hot, but they're not very bright because of their size. All right, comets, what are they made of? Remember, people refer to them as dirty snowballs. Jaren?
Dirt and ice.
Not dirt so much, but ice is right.
Ice and asteroid dirt. Rocks.
Okay, rock, ice, and frozen gas. Frozen gas, okay. And where are they found primarily? Where are comets found? Colton?
Like in like the outer rims of
Right, outer rings of the solar system, and they actually orbit the sun. Comets orbit the sun as well. Asteroids, what are they made up of? Luke?
They're made up of rock from the asteroid belt.
Good, primarily rock and metal. Where is the asteroid belt located? Luke?
Between Mars and Jupiter.
Between Mars and Jupiter. All right, moving on to atmosphere. What are the two most abundant gases in our atmosphere? Rihan?
Nitrogen and oxygen.
Yes, nitrogen by far is the most, oxygen is second. What are the layers of the atmosphere? I wonder if I can write over here. Who wants to start closest to Earth? Sarah? Okay. What's next? Keep going. Stratosphere. Keep going. Yep. Did you say thermosphere? Okay. And the thermosphere is really made up of which two? Good. Ionosphere and exosphere. So on the exam, I would either give you these 5, or I would give you those 4. If I asked you the order, does that make sense? I would not include all 3 of these because I think that's confusing.
That was confusing.
Does that make more sense how I've drawn it? Okay. So if I ask the order, remember it's multiple choice. It's either going to be these 5 or just those 4. All right, how does, I'm gonna actually do this backwards. How does density change as you go up in our atmosphere? What happens to the air molecules? Do they get further apart or do they get closer together as the further you go up? Noah?
I think they get closer together.
As you go up? Is it easier or harder to breathe at higher elevations? Like up in the mountains?
Harder,
It's harder, so they're probably what?
spread out.
Yeah, so density actually decreases as you go up. What about pressure? Remember that column of air sitting on top of us? If we go up in altitude, that column gets shorter. So what happens to pressure, Sanjay? Decreases. And temperature changes according to a pattern. Guys, the reason that these layers exist is because the temperature changes. It changes as you go up. That's why they actually divided these into layers. In the troposphere, the temperature goes down. It gets colder as you go up. In the stratosphere, temperature gets warmer. Mesosphere, it gets colder. And in the thermosphere, it gets warmer. It changes. That's why they're divided like they are. Yeah, Rehan.
And by the thermosphere, it's hotter on the upper edge and it's colder on the bottom.
For this layer,
Yeah.
correct.
Okay.
Yeah. Okay. I think we answered all those. Air pollution and ozone. What is ozone? I mean, it's a good thing, right, when it's up in the stratosphere. So what is ozone? What do you have down? Lucia?
Ozone is a gas composed of 3 atoms of oxygen.
Yeah, so this is just amazing about chemistry. So the oxygen that we breathe is O2, meaning it has 2 atoms of oxygen. This is what we need to survive. If you add on 1 more atom of oxygen, it becomes a totally different molecule called ozone, which is dangerous for us to breathe. So that's kind of amazing how chemistry works. So this is oxygen that we breathe. this is a picture of what ozone would look like. Now it's great because when it's in the stratosphere, what does it protect us from?
Sun's UV rays?
Yeah, it's like a natural sunscreen. But when it's at our level, it trickles down into our level, what can happen, Isak?
It can, like, disturb, satellites.
No. It's a pollutant and it actually affects breathing. It can actually affect people, and their breathing. Alright, natural causes of air pollution include what? These are things out of our control that happen and add to air pollution. Sanjay?
Volcanoes erupting,
Volcanoes, what else?
Like soil erosion and dust storms,
Erosion, dust storms,
forest fires.
forest fires, which can be human caused or natural, right? If lightning strikes. Okay. Human causes of air pollution. Forest fires could go on there again. Luke,
For natural, does decaying of organisms count?
say it again.
For natural, does decaying of organisms count?
No. It's not a major factor in air pollution. No, burning fossil fuels, guys, is number one for humans, right? And that includes a whole lot of different things. Sarah, farming and construction. Good. Primary cause of air pollution on Earth is, of course, boom, right there. Burning oil, coal, and natural gas. All right, greenhouse effect. The greenhouse effect works like an actual greenhouse, right? Stella, what does it do?
So the sun's energy goes into the Earth's atmosphere and only bounces off the Earth and then goes back in the
Awesome.
atmosphere, but then it bounces back.
Great, it gets trapped, right? The sun's energy kind of gets trapped by Earth's atmosphere. And it allows for us to exist, quite honestly. Without it, we wouldn't be here, okay? So we need the greenhouse effect. That's a good thing. All right, carbon cycle. What is the, what kind of things, activities add carbon to the atmosphere? Remember back to the carbon cycle diagram you drew. Rihan, what adds carbon?
The burning of fossil fuels.
Okay. Keep going, what else?
Animals dying.
Not that only, animals dying adds carbon to the soil. I think that's kind of what you were thinking too, Luke, but animals breathing, and including humans, right? We breathe out carbon dioxide, so that's gonna add carbon to the air. How does the amount of carbon in the atmosphere affect climate? The more we're doing this, in other words, the more carbon is going into the atmosphere. Elena, what happens to the climate then?
the carbon dioxide gets trapped in the atmosphere and it just like adds to the greenhouse effect, like making it too warm.
Good. So again, more gases, more carbon in our atmosphere means more heat can be trapped, warming the climate. Types of fossil fuels, there are three: coal, oil, natural gas. What is the water cycle? It's the continuous movement of water on our Earth. The water that Earth started with, we still have today. That water never disappears. It never is created. More is not just created. It has stayed in the cycle forever. So yeah, the water that we have today is the same water that was around when the dinosaurs existed. So sketch and label the water cycle. Does anyone need me to go over that? I think you have that in your notes. Any questions about it? It's just knowing the different, I would know the different definitions of these things.
Will the definitions be like? would
Guys,
that
it's
be-
multiple choice. It is multiple choice.
And I'm saying if that'll be a question.
You might be asked something in which you have to recall what those things are. All right, here's the deal. I did not get a chance to get through this last bit. So that's perfect because on Thursday afternoon, I have 30 more minutes with you. So during that 30 minutes, I'm gonna finish up this and then we'll do some more sample questions for the exam. All right? Have a great day, everybody.